Lenz's law has many applications, especially due to the global technologies shifting towards renewable energy rather than fossil fuels. It is imperative that electric motors are well understood and documented. An electric motor is a device that converts electrical energy to mechanical energy. Boyd-Savart law describes the magnetic field generated by a steady electrical current, stating that the field strength at a point is proportional to the current and inversely proportional to the distance from the electrical element. It calculates the magnetic field strength from the current-carrying wire segment using the cross product with the displacement vector. This specific application of Lenz's law in conjunction with the Boyd-Savart law that this experiment will test is measuring the change in EMF, which is proportional to the velocity, and using the data to calculate the experimental value of gravity, which will then be compared to the true value of gravity to determine if the experiment is a success. This experiment requires cylindrical neodymium magnets 12 mm in diameter, a transparent acrylic tube 12.7 mm in diameter, uniformly wrapped with coils of copper wire that are insulated, and a digital oscilloscope with voltage probe to measure the induced EMF. The methodology involves dropping the magnet through a tube with a loop of wire in 3 separate places. The oscilloscope is then connected to each loop of wire, and the readings will be recorded. Multiple trials are conducted to ensure reliability, with careful attention given to maintaining consistent drop height and alignment. Air resistance was ignored due to the tube reducing any wind. The change in velocity will be due to gravity, so the velocity calculations will be plotted on a graph and the gradient will represent the experimental value for gravity. After the data was collected, it was entered into a linearized formula, and the uncertainty of the change in gradient was calculated. It was found to be plus or minus 0.6 meters per second. The mean value for gravity was 9.97 meters per second squared. This demonstrates that the results of the experiment were valid and somewhat accurate. The error of the gravity value discovered was only 0.3 meters per second squared, meaning the accuracy of the experiment was moderately high. The precision of the experiment was acceptable as the experimental value was close to the true value within the uncertainty of the experiment. It is evident that more data should be taken to make the experiment more accurate and precision could be improved.